Hello, welcome to this video series on MDX for SQL developers. I'm Nasir Ali Mirza at DoSQLBI.com. This video series covers the building of the MDX language skills in the SQL developers. In the previous session, we had a high-level look at OLTP and OLAP database in comparison. In this video, we will take a look at MDX terminology. We'll see what is meant by dimension, major group, attribute, what do we mean by children, members, tuple, tuple set, sets, access, hierarchy, and level, and what is a major's dimension. I have a connection open to the AdventureWorks DW 2012 OLAP DB, and we'll take a look at what are the dimensions in this OLAP DB. You see, it has a list of dimensions starting with account, customer, date, and many more. Dimensions are like lookup tables of OLTP database. They are built from one or more source tables. For example, product dimension is created from product category and product subcategory table in the OLTP database. Dimensions contain attributes. We also call them as attribute hierarchies. So attribute category, model name, large photo, product, subcategory. Some of the attributes have been put under a folder view just to categorize them. So you have a financial, under that there are dealer price, list price, standard cost. Similarly, there is history. Other than attributes, there are user-defined hierarchies. You see product category here, product model lines. We'll be covering later what are these user-defined hierarchies and related concepts. Each attribute contains a distinct list of values. For example, in product dimension category attribute, its distinct values or members are accessories, bikes, clothing, components. After looking at what are dimensions, which are like lookup tables in OLTP database, let us see what are major groups. So what is a major? Transaction tables in OLTP database contain the transaction data in various columns. Those columns in OLAP database become majors, which can be grouped into different major groups. In the sample database that we are looking at, under majors, we see a list of major groups starting with exchange rate, financial reporting, internet customers, internet orders, and so on. These major groups correspond to the OLTP database transaction tables mostly. Let's take a look at one of the major group. You see internet sales here contains a list of majors. Its example is internet sales amount, internet freight cost, internet tax amount. So these are various majors. There are some calculated majors like internet gross profit, growth in customer base. These are calculated majors. Earlier in the earlier session, we saw in the MDX query structure you can define calculated member. So these are those calculated members. In the later sessions, we'll see how to create them and how to use them. Each of the major group in the OLAP database will have a well-defined relationship with the dimensions in the OLAP database. That relationship is defined as part of the OLAP database designing. After taking a look at dimensions and major groups, we'll now see what are attributes, children, and members. Let me switch over to SQL Server Management Studio. So what are attributes? Attributes are like columns in a table in OLTP database. Let's take a look at this geography dimension. There are two types of attributes: attribute hierarchies and user-defined attribute. In this geography dimension, geography attribute is a user-defined hierarchy, and rest of them, ST, country, postal code, state, province, are attributes or attribute hierarchies. The way column in a OLTP database contains one or more values, Similarly, attribute will have one or more values. Let's see what are the different values of a country attribute. So we see names of different countries here. Every attribute will have a single level in its hierarchy. So in a country attribute, it has only one level. You see, when I hover over this, I see level equal to country. So country attribute has a one level as country. Every attribute will also have one system added data member with the name all. At the design time, we can decide whether we want this member to be added or not to be added. By default, it's added. In a SQL query, you can reference a column name and then pull all its values. In MDX query, you can do same. You can refer the attribute name and pull all the data values in that. But it also supports referring any particular data member of an attribute directly. And in fact, it supports it in two ways. You can access it with the key name of that data member of an attribute, or you can refer it with the name of that data member in an attribute. Let's see this United States as one of the data member, how we can access various ways the attributes of a dimension. So in dimension geography, I have a country attribute. I can access it with the attribute name, so geography.country. I can access it with adding a suffix .children. What that is we'll cover in a while. You can access it again with the attribute name .members. We can access a particular member data value, that's United States here, with a key. Now when you refer that with a key, you add this ampersand and then the key name. You can also access that data member with its name. So the name of that data member is what you see here as United States. It apparently looks, we have it similar, but they can be different. So way to identify whether you are accessing it with key or a name is that you will have this ampersand before the key. Let us see what is the difference between using children and members. Let's see that in a query. I have two queries, one where I am accessing country attribute of a geography dimension with children. The same query where I am accessing that attribute with the members. Let's run it one by one. What I see as an output is the name of the countries and beneath that default major values. Now I run the other one, which is with members. What do you see the difference? This all geographies. So I again get the same list, name of all the countries, beneath it the default fact major value, all geographies. So the difference is when I use children, I don't get the all default member, and if I use members, I get all the attribute values including the all member that is added by the system in the design that has been mentioned. So after taking a look at what is attribute, children and members, we'll talk about what is a tuple, what is a tuple set, what is set and what is access. In a SQL statement, we put columns from one or more tables into a statement. Similarly, in an MDX query, we put together one or more attributes from one or more dimensions. That makes a tuple. Let me switch to SQL Management Studio and we see an example. I had this query already written. Let us concentrate on this part. It starts with an open curly bracket and close curly bracket on axis 1. We'll talk about it when we talk about sets. Then inside that there is open bracket and closing bracket. Think of this as what we put in SQL statement, the list of columns after the select keyword. This is a tuple, and this tuple contains two attributes, country and category. And country I am directly referring to Australia, and category I am directly referring to accessories. So this we say is a tuple with two attributes, one of them being country, another being category. On another axis, I have another tuple where I am referring to majors dimension, reseller sales amount. Let us run this query. The output we get is, it says, country name is Australia, where the accessories reseller sales amount is this particular figure. Let us see another example. I have that query written here. This is another query which has a tuple. Again, it uses two attributes, country and category. Similarly, there is on another axis another attribute which is referring majors reseller sales amount. Now let me run this MDX query. The difference between the earlier one and this one is I see multiple rows as an output. So to say, this tuple here where I am referring country attribute and category attribute, country attribute I am using children, so it is going to return all the data members in a country attribute. I get multiple rows as an output. So we say this tuple is basically a tuple set. It returned a result set compared to the previous one which is returning only a single row. That is the difference between tuple and tuple set. Let us see another example. I have one more example already written here. Now what do we see in this example? On axis 1, I see two tuples. This is tuple 1, this is tuple 2. So this is somewhat like in SQL statement. I can put together multiple statements in a union. There are certain rules that govern what you can and what you cannot do. Similarly, in the later sessions, we'll see that what are the rules that we need to follow when we put multiple tuples on an axis. Now let me run this statement and see what we get as an output. What we had done in these two tuples is on an axis, again a geography, country attribute and children, but in the products I had specified as accessories. I am repeating them in the second tuple, the attributes geography and country, but in this case product category is referring to bikes. So I see in Australia as a country accessories is this amount, Canada accessories is this amount. Then I see in second tuple on that axis returns Australia, what are the bikes, Canada, what is the sale of bikes, and so on. The other difference you will note here compared to the SQL statement is we don't have explicitly mentioned the join statement even when we are pulling some data from different dimensions. So I'm getting country from geography dimension, I'm getting category from the product dimension, but this whole statement doesn't have anywhere an explicit join statement. The other thing to notice is I cannot add an empty tuple. Empty tuples cannot be added, which means I cannot do something like if I want to delete this, this is not valid. I cannot run this statement. It will just throw an error. Empty tuples are not allowed, but empty sets are allowed. If I altogether remove this tuple from here and I just keep an empty set, now I run this statement. It's showing me the results, but because I am not referring to any majors attribute, so I get an empty set. To sum it up, in this video we looked at what is a dimension, what are major groups, what are attributes, children, members, tuple and tuple set. In the next video we will cover the remaining items of this topic.